Okay, we have a bunch of rational functions here. We want to get to be really good with rational functions. So we have 1, 2, 3, 4, 5, 6 tasks here. First, we want to find the domain of the function, of each function, right? Then second, we want to reduce the rational function to its lowest terms, if possible. Third, we want to find the x-intercept and the y-intercept. And then we want to determine the location of any vertical asymptotes or holes. Holes also called removable. Then 5, we want to analyze the end behavior of each function. And maybe find horizontal asymptotes or slant asymptote. So in the end, we want to use a sign diagram and plot additional points to sketch the graph of rational function. Yeah. Let's see the first one. We have, so I have to erase this and to move forward. So we have how many? 1 through 10. 1 through 10 questions here. All right, to do. And then the solution is already done. So we just go through the solutions. So in order to do faster. So first, let's look at the domain. So this is our first question. So what is its domain? How do we find its domain? We take the denominator, right? Denominator in this case is x squared minus 9. And we say, okay, this cannot be 0. Because in mathematics, dividing by 0 is illegal. We never see one apple shared by 0 people. Does not exist in mathematics. Okay, we never dividing by 0. So 0 will never be a divisor. Then this is the difference of 2 squares and can be factored as x minus 3 and x plus 3. Now, of course, those two not equal to 0, that means x not equal to 3 and x not equal to -3. So x can be any real number except positive 3 or -3. Or we can write it in interval notation. So this is called interval notation. So it goes to -infinity up to -3, then union -3 up to 3, union 3 to positive infinity. So how do we understand this notation? With so x value in one dimension. Let's see, 0 sits in the middle. Towards the right of 0 is positive. Towards left of 0 is negative. Right? So what's in the very end, we call -infinity. What's in this right end, called positive infinity. Infinity is just ideas, so it's not a number. So whenever we talk about infinity, we use open parentheses. Right? Open parentheses. So in this case, 3 and -3 not in the domain. So 3, let's see, is here. -3 is here. Not in the domain means the value of 3 is omitted. So usually we indicate it with an open circle. Indicate it with an open circle. So then all other x values, so from -infinity up to -3, but not including 3. Not including 3, we use closed parentheses or open parentheses to indicate. So that's from this down to -infinity. And from -3 to 3, we have also not including -3. and then not including 3. So we use open parentheses and close parentheses. That's for from here to here. Then lastly, it's from 3 to past infinity. So not including 3, we write it with open parentheses. For infinity, it's just an idea. We use close parentheses. Right. So we have 3 pieces. What do we do with these 3 pieces? We unit. So this sign means unit. Unit. Right. So put those 3 together. So that's why we have this. Okay, close parentheses, open parentheses, close parentheses, open parentheses, just for omitting -3 and 3. So we want to find x-intercept, right? How do we find x-intercept? X-intercept means the y value, the function value is 0. So x-intercept. The definition of x-intercept is some x value, but the y value is always 0. Right? Because when we graph on a plane, the points are called x-intercept that fall on x-axis. So those points, the points on x-axis are called x-intercept. And the y value are 0. Y value is always 0. So we just set this value, the function value, to be 0 for this rational expression. Then this rational expression to be 0 means the numerator is 0. Means this numerator is 0. So I have 2x squared minus 9 equals 0. That means 2x squared equals to 9. Right? We divide by 2 on both sides. We get x squared equals to 9 over 2. Then we square root both sides. When we square root both sides, we get plus minus. Right? We square root this side. We square root this side. When we square root, we get a plus minus 2 values. Square root 9 is just 3. Square root 2 is an irrational number. So we keep inside the square root. So we have 2 x-intercepts. Right? It's a plus minus 3 over 2, 3 over square root 2, and 0. So that's how we get those 2 values. Right? But it's better to write as this, because as a point, intercepts are points. So y-intercept, how do we find a y-intercept? It says y equals to 1. Y-intercept means x value is 0. Right? When x value is 0, we just plug in 0 for x. X is 0, this one will be 0. X is 0, this term will be 0. So the numerator left with -9, the denominator left with -9. -9 divides itself, that's 1. Vertical asymptotes. Vertical asymptotes come from the domain, right? Because 3 and -3 is not in the domain, so we have 2 vertical asymptotes. When x equals 3, vertical asymptotes you can think as like a prohibited line. The graph won't cross the line. So I have those two. So this is a -3, x equals -3. This is x equals 3. So I have those two vertical asymptotes. What about horizontal asymptotes? Horizontal asymptotes we find from those two. We basically ignore -9, the constant term. So 2x squared divided by x squared, that's 2. So y equals 2 is the horizontal asymptote. So it's somewhere here, but if we write a line across this, so this is the horizontal asymptotes. Now these vertical asymptotes usually we write as a dotted line. We don't write as a solid line. So this is a graph of this rational function. Okay, this is a graph of this rational function. It has 3 pieces. That's the second question. This is a second function. B of x or f of x equals x over x minus 1. For domain obvious, x minus 1 cannot be 0. That means x cannot be 1. X, this function works for all real numbers except 1. So we write in the interval notation in this way. Well, the function intersects. So what's x-intercept? X-intercept means y equals 0, right? If the function value is 0, that means the numerator is 0. So 0, 0. The origin is called 0, 0. It's 0 for x value, it's 0 for y value. Well, if the origin is x-intercept, it's also y-intercept. So it's both. A vertical asymptote at x equals 1 comes from domain, right? Comes from domain. Y equals 1 again comes from the leading term in the numerator divided by the leading term in the denominator. X divided by x, that's just 1. So y is a horizontal asymptote. So the graph looks like this. The graph looks like this. So vertical asymptote, horizontal asymptote is not drawn here. Y equals 1, so this is 1. Asymptotes usually we draw the dotted lines. And so this graph will never cross this line. This graph will never cross this line. That's what the function of asymptotes. Let's see, third question. Third question, we have x minus 2 in the denominator. So the domain of this function is all real numbers except 2. So we write in the interval notation like this. Well, the rational function has zeros when x equals -3. That means x-intercept. Zeros means x-intercept. So when the function is 0, that means the numerator is 0. Numerator is 0, x plus 3 equals 0. That means x equals -3. So the x-intercept is -3, 0. X-intercept and y value is always 0. The y-intercept is x0. Well, that's obvious. X0, 0, we get -3/2, right? So 0, comma, -3/2 is a y-intercept. Vertical asymptotes from the domain x equals 2. Right, then y equals 1, x divided by x, y equals 1 is a horizontal asymptotes. So to graph this according to what we have, we get the following graph. We get this graph. So we see x equals 2 is a vertical asymptote. Y equals 1 is a horizontal asymptote. Okay, asymptotes x at prohibited line. So this piece of graph will never cross the vertical asymptote and horizontal asymptote. And this graph also will never cross vertical asymptote and horizontal asymptote. Number 4, the denominator will have 2 factors. So we set this one not equal to 0 to solve, right? Then x minus 3 is not 0. So that means 3 is not in the domain. X minus 4 not equal to 0. That means x not equal to 4. That means -4 is also not in the domain. Writing the interval notation means all the numbers from -infinity up to -4, not including -4. Union from -4 to 3, not including -4, not including 3. Union 3 up to infinity, not including 3. So this is called interval notation. Or x-intercept, or zeros, which means the numerator is 0. When the numerator is 0, x equals to -1, or x equals to +1, right? Set this one to be 0, set the numerator to be 0, solve for x. So we have 2 x-intercepts, -1, comma 0, and 1, comma 0. Basically plus minus 1, plus minus 1, comma 0, 2 x-intercepts. What about y-intercept? Y-intercept means x equals 0. So 0, this is gone, 0, this is gone, 0, this is gone, 0, this is gone. Well, 1 times -2, which is -2 in the numerator. -3 times 4, -12. -2 divided by -12, that's 1/6. The x value will be 0. So the y-intercept is 0, comma, 1/6. X value is 0, and y value is 1/6. Vertical asymptotes comes from the numbers not in the domain. So -3 is not in the domain, -4 is not in the domain. So 2 asymptotes, vertical asymptotes. When x equals 3, when x equals -4. Well, horizontal asymptotes coming from the leading terms of the numerator dividing the leading term of denominator. The leading term in the numerator is x times 2x, which is 2x squared. Leading term in the denominator is x times x, which is x squared. 2x squared divided by x squared, that's 2. So y equals 2 is a horizontal asymptote. With all this information, now you can sketch the graph. Notice it's a sketch, it's not exact sketch. So we have those 2 vertical asymptotes. We have a horizontal asymptotes at a y equals 2, somewhere here. So this one is similar, just with a little bit more difficult numbers to deal with. Domain from the denominator, so 2x plus 3 not equal to 0. They give us not equal to -3/2. 3x minus 4 not equal to 0. That gives us 4/3. And x cannot be those 2 numbers. Already in the interval notation, already in this case, x-intercepts y equals 0, or the numerator to be 0. We solve, that's x, not x equals half, x equals -2. So 2 x-intercepts or zeros. Y-intercept, taking the leading term again, numerator has a leading term of 2x squared. Denominator has a leading term of 2x times 3x is 6x squared. 2x squared divided by 6x squared is 2 over 6, simplified to be 1/3. So y-intercept is 0, comma, 1/3. Vertical asymptotes from the domain, x equals -3 over 2, x equals to 4 over 3. So 2 vertical asymptotes. Horizontal asymptotes is also, right? Oh, y-intercept comes from x to be 0. X to be 0, this is gone. X to be 0, this is gone. X to be 0, this is gone. X to be 0 is gone. So I have -2 divided by -12, which is 2 over 6, which is 1 over 3. Horizontal asymptotes come from a leading term, 2x squared divided by 6x squared, which is 2 over 6, simplified to be 1 over 3. So now with all this information, we can sketch our graph. So graph looks like this. For this piece, for this piece, we have a piece in the middle. We have 2 vertical asymptotes with 1 horizontal asymptotes. Well, let's see question 6. So the denominator needs to be factored. So we need to think of factors of -6 adds up to be 1. Well, probably we factor -6, we have to as +3 times -2, right? Because 3 minus 2 is 1, which is the middle term, right? So this is the middle term, so the number before x is 1. So this 1 comes from adding the 2 factors of -6, which is 3 and -2. So that means we can factor x squared plus x minus 6 to be x plus 3 times x minus 2. Right? So the denominator can be factored as those 2 factors. That means x cannot be -3, x cannot be 2. Right? So those 2 numbers not in the domain. But in the interval notation to omit them, we have this. What about its x-intercept or its zeros? 0 means the numerator is 0. X squared minus 1. That means x squared equals 1. That means x equals to plus minus 1. And of course, y is always 0, right? X-intercept, y always 0. For y-intercept, x is 0. X is 0, this is gone, this is gone, this is gone. We're left with -1 over -6, becomes +1 over 6. So y-intercept, x value is 0, y value is 1 over 6. Vertical asymptotes comes from the domain, right? 2 is not in the domain, -3 not in the domain. The 2 vertical asymptotes is x equal 2, x equal -3. Horizontal asymptotes comes from the leading terms. So x squared divided by x squared, that's 1. So with all this information, we can graph again, can sketch. Right? Sketch again. So I have 3 pieces. Similarly, for 7, we just need to factor the denominator, right, to find the domain. So denominator, we see we have 3x squared plus x minus 4. We're thinking the distance between 4 and 3 is 1. So we want to factor as this, 3x minus 1. Oh, no, minus 4 times x minus 1. So 3x plus 4 times x minus 1. Because 3x times x, 3x squared. 4 times -1, -4. The middle term comes from 4, from those 2, from 4x minus 3x, which is +1x. Right. To solve this, we get, so denominator cannot be 0. So for the domain, That means x cannot be -4/3, and x cannot be 1. And those two numbers give us two vertical asymptotes, x equals 1, x equals -4/3. And domain, we can write in the interval notation as this. Find the zeros or find the x-intercept. We set the numerator to be 0, x squared minus 4 to be 0. That means x minus 2 times x plus 2 to be 0. So x equals plus minus 2. Okay, so y value is 0 because this 0 means x-intercept. Y-intercept means x value to be 0. So this is gone, this is gone, this is gone. We have -4 divided by -4 is 1. So y equals 1 is a horizontal asymptotes. Y equals 1 is, okay, so 0, 1 is the y-intercept. And taking the leading term in the numerator, taking the leading term in the denominator, x squared divided by 3x squared, that's 1/3. So y equals 1/3 is a horizontal asymptote. With all this information, now we can sketch our graph. So our graph looks like this. 2 vertical asymptotes, 1 horizontal asymptote, which is not showing here, the 3 pieces. Okay. Let's say number 9. Again, we need to factor this. Right? If the denominator is not in a factored form, we need to factor it. So we want to factor the denominator as x. X is a common factor of x cubed and 4x. Once we factor out, we see we have x squared minus 4. That's difference of 2 squares can be factored as x plus 2, x minus 2. So set this one not equal to 0, we see x cannot be 0, x cannot be 2, x cannot be -2. So those 3 values not in the domain. Those 3 values not in the domain, it creates 3 vertical asymptotes, right? So one vertical asymptote is the y-axis, which has another name, x equals 0. And then with a vertical line, x equals 2, and a vertical line, x equals -2. So we have 3 vertical asymptotes. Well, horizontal asymptotes coming from the leading term again. We have x squared divided by x cubed. Simplify, that's 1/x. Right? Horizontal asymptotes means think about x goes to positive infinity or negative infinity. So this number will tend to 0, right? One apple shared by the, all the people in the world. How many apples each one gets? Nothing, right? Nothing. So when x grows bigger and bigger, so 1/x grows smaller and smaller. So in the end, it tends to be 0. So that's why the horizontal asymptotes is y equals to 0. With all this information, now we can sketch our graph. Our graph has 4 pieces. That's 4 pieces, right? Let's say 10. 10, we're not able to factor our denominator, right? We're not able to factor our denominator. We think, okay, will the denominator ever be 0? If you use you can use quadratic formula. Quadratic formula is x equals to -b or plus minus square root of b squared minus 4ac divided by 2a. And where does a come from? A is the number before x squared, b is the number before x, c is a constant number. Right? When you do that, you see you get the discriminant is negative. You get a square root of -3, which does not exist in real number system. So basically we're seeing this denominator will never be 0. So that means its domain is all real numbers. It works with all numbers. Okay, find the x-intercept, right? The 2x plus 1 is 0. That means x equals to -½ and y value is 0. Find the y-intercept, means x value is 0, 0. We have 1/1, which is 1. So y-intercept is 0, 1. It has no vertical asymptotes, right? Because it works for all numbers. And then y equals 0 is a horizontal asymptote. Okay. Y equals 0 is horizontal asymptote. Because again, we simplify those two leading terms, we get 2 over x. As x go to the left or go to the right, it tends to be negative infinity or positive infinity. 2 over infinity becomes 0. So we have y equals 0 as a horizontal asymptote. Well, y equals 0 is x-axis, right? All the points on x-axis has a y value to be 0. So with all those information, now we can sketch. So our graph looks very weird, right? It looks like this. So that's why rational functions are kind of difficult to graph. So those are a couple of, 10 questions, but we did it in detail, 9 of them to show, these are different kinds of rational functions with different kinds of graphs.